Hello everyone, welcome back. Hope you are eagerly waiting for this module. I am Dr. Navjot Karkaval, here to present a module on processor. Dear student, let us know about the CPU or the central processing unit, sometimes referred as the central processor or more commonly called as processor, which carry the responsibility of running all the instruction on its shoulder, called as the brain of the computer where all computing is done. A modern CPU is usually small and square in shape, with many short rounded metallic connectors on its underside, and sits directly on the motherboard at the CPU socket or slot. By now, you must be knowing that a computer receives input through various input devices like keyboard, mouse, and produces desired output after being processed by the processor, where lot of arithmetic and logical operations are performed, and finally to store information in storage device like hard disk. Remember, the choice of processor will affect the ultimate speed of the computer more than any other single component in the computer, because it controls and coordinates the activities of all other components of a computer system. The modern PCs are called microcomputer because of the microprocessor working inside them. How the processor works? The CPU has to work hand to hand with the main memory or RAM, the random access memory, which contains all the data and instruction being processed by the CPU at a given point of time, which are stored at the precise addresses in the RAM. There are a list of instructions stored in the RAM called instruction set for taking input and output, and then there is load, add, store, compare, jump if and jump instructions. RAM also store intermediate and final result of the processing. Let's now get inside the CPU and look at the different components of the processor. A central processor unit consists of three main components: the ALU, the arithmetic logic unit, the control unit, the registers, and lot of buses. Let's first look at ALU or the arithmetic logic unit. The arithmetic logic unit contains the electronic circuitry that executes all the arithmetic and logical operations, where the arithmetic unit is responsible for all kind of arithmetic operations or mathematical calculations like addition, subtraction, multiplication and division. Even complex operations are done by making repetitive use of such operations. How ALU would know which operation is to be undertaken? So, it is controlled by signals from control unit. As its name implies, the arithmetic logic unit also performs logical operations. Logicals means comparison between two pieces of data. The duty of logical operation is to compare two things so that it can compare numbers, letters or special characters. The computer can then take action based on the result of comparison. Logical operations can test for conditions called relational operators. The most common relational operators are equal to, less than and greater than. The type and number of arithmetic and logical operations that a computer can perform largely depends on the designing of ALU, which make the CPU stronger. Then let's see what are registers. For performing any arithmetic or logic operation, an arithmetic logic unit requires some temporary memory locations where data and instructions are kept for short while. Such memory locations built in ALU are called registers that enhances the speed of processor. Registers also work under the direction of the control unit to accept, hold and transfer instructions or data and perform arithmetic and logical comparison at high speed. Such registers are like stock book of the processor, which keep a record of all data coming from processing. How much has been used, where to get it, where to store it, what is in the transit, everything is being stored there. Registers are of different types depending upon the special functions being assigned to them. There are general purpose registers, address registers, storage register, accumulators, status registers, program counters and stock pointers. A general purpose register is one which can be used for any temporary storage purpose. They can be paired to handle large size data. And address registers keep a track of where a given instruction or piece of data is stored in memory. Each storage location in memory is identified by an address, just like each house on the street has an address. A storage register temporarily holds data taken from or about to be sent to the memory. Then there is accumulator, which collects or accumulates the results of computations. Then there is status register, also called as flag register. They indicate the current status of the processor by setting the individual bits called flags. Program counter. This register is there to find the next instruction for execution or deals with the order for execution of instructions. Act like a pointer which indicates the subsequent memory location where instruction is to be stored. And then there is stack pointer, where stack means set of consecutive memory locations, and stack pointer may be defined as the indicator to these memory locations. Let us now see what is control unit. As the name suggests, this component controls all the functions that take place inside the processor and tells rest of the computer system how to carry out a program instruction. Control unit is like a traffic controller standing at the crossroad, managing all the traffic efficiently. Similarly, a control unit monitors the execution of all the instructions and transfer of all the information, responsible for sequencing operations and ensure the correct data is reaching at the correct place at correct time. The control unit of the CPU contains circuitry that uses electrical signals to direct the entire computer system to carry out or execute stored program instructions. It has to communicate both with arithmetic logic unit and memory to obtain the instructions from the memory, interpret them and direct the operation of the computer. It also communicates with input-output devices for transfer of data or results from storage. Remember, it does not process or store the data itself, but direct other components to do so. So, all the computer resources are managed from the control unit. Then there are many buses which connect address, data and control instruction together. A bus is the collection of wires through which data is transmitted from one part of the computer to another. So, act as a highway for transferring data. It consists of multiple lines allowing the parallel movement of the bits. They are low cost but very versatile and make it possible to even connect to new devices, like there is expansion bus that enables expansion boards to access the CPU and the memory. All buses can be categorized as an address bus, a data bus and a control bus. Address bus identifies the particular location in the main memory and from input-output devices from where data should be either read or written. The width of the address bus, that is number of wires, determines how many unique memory locations can be addressed. Where data bus, they are the lines of buses dedicated to moving data. These lines contain the actual information that must be moved from one location to other. The size of data bus is also important because it decides how much data is transferred at a given time. For example, a 16-bit data bus can transmit 16 bits and 32-bit data bus can transfer 32 bits. Remember, the data bus width is often used to categorize processor like 16-bit processor, 32-bit processor or 64-bit processor. So, a 64-bit processor is more powerful than 32-bit processor because it can handle more data. Then there is control bus. The control bus is used to control flow of data, that is to read or written the data from the memory. At a given point of time, only one device, either it is register or ALU or memory or some other component, may use the bus. Therefore, speed of the bus is affected by its length as well as the number of devices sharing it. Each type of transfer occurs within a bus cycle. The time between the two ticks of bus clock. Every bus has a clock speed measured in megahertz. A fast bus allows data to be transferred faster, which in turn runs application faster. Dear friends, as mentioned, CPU is the place where all instructions are executed, which are stored in main memory. To accomplish this job, processor takes a series of steps called as machine cycle, which consist of fetching, decoding, executing and storing. Where first two steps, that is fetching and decoding, forms the instruction cycle and the last two forms the execution cycles. In fetching step, the control unit must fetch commands or data from the computer memory into the instruction register. In decoding step, fetched commands are decoded into instructions by control unit, which are referred as CPU instruction set. Then in execution cycle, CPU executes the instructions by converting them into the microcode. Remember, microcode is the lowest level of instruction that are directly control a microprocessor. And in storing step, CPU stores the result in the memory. Let us now move further and discuss some of the key characteristics related with processor, which you must know. First is CPU interface. The CPU interface is the plug that your processor goes into for your processor to physically fit in the motherboard. The interface must be an exact match to your processor. Then there is IPC or the instruction per cycle. It is the amount of work a CPU can do in a cycle. Then you must have heard about the phenomena of clock speed with regard to processor. It is the number of calculation cycles that the processor can perform per second, measured in gigahertz or megahertz. Therefore, a higher clock speed, faster is the processor. Let's now see what do you mean by overclocking in reference to processor. Overclocking means the action of increasing the component's clock rate, running it at a higher speed than it was designated for. Overclocking usually risks your entire computer. So, be conscious and think hard about cooling the computer as overclocking generates lot of heat. Dear friends, when you buy a processor from a shopkeeper, he gives you some specification regarding bit width, which generally refers to the size of the chunks of the data that the CPU can work with, as we have already discussed. Almost all modern processor currently supports 32-bit and 64-bit. That means they can process and transmit 32 and 64-bit in parallel. Then we usually talk about the cache in reference to processor. It is a little portion of fast memory mounted onto the CPU chip, which stores copies of files that are frequently used to operate different applications and enables the processor to fetch data quickly instead of relatively slow RAM memory. Generally, the larger the cache, the faster is the system will run. Cache usually comes in three variants, L1, L2 and L3. L1 is the smallest and fastest, L3 being the largest and slowest. What do you mean by core? You hear about a processor. A processor core, for simply called as core, is an individual processor within a CPU. Many computers today have multi-core processors, meaning the CPU contains more than one core. For many years, computer CPUs only had a single core, but in modern computers, we have multiple cores. So, a processor with 2 cores is called as dual core processor, with 4 cores a quad core, a 6 cores hexa core, and 8 cores means octa core. Multiple core processors have the ability to turn off one or more of their cores when the application demand is low to save power. CPUs with 4, 6 and even 8 core have already been released. Many laptops now feature quad core, with desktop possibly featuring 6 to 8 core. Servers can have even more, all the way up to 18 or even more than that. Back in 2005, multi-core were fairly new and were expensive, but now all computers at least have 2 cores. This technology has reduced the need of multiprocessor CPU system, which were expensive and had drawbacks. Such multi-core technology is very common nowadays and built by both major processor manufacturers, that is Intel and AMD. Then we have multitasking processor nowadays. That means you can type a Word document, you can also play your favorite song side by side, or the concurrent execution of multiple tasks. Then there is phenomena of hyperthreading. Hyperthreading is an Intel technology which allows a single core processor to simulate having 2 cores, giving the performance boost when running several programs at once. It requires motherboard and chipset supporting hyperthreading technology. Then there is CPU cooling. CPU cooling is very important and should not be overlooked. Extremely high temperature can cause immediate CPU destruction by melting the material in the chip and changing the physical shape of the sensitive transistors on the CPU. Dear friends, present day microprocessor has come a long way to get into the present form. Let us now have a quick look at the progress of microprocessors. Look at your screen. This is almost where we started. This is the CPU of Universal Automatic Computer or UNIVAC in 1956 being pushed up to the ramp, and somebody saying, you know, someday all of that will fit on the head of the pin, which is a reality today. Presently we are working on microchip, and we could also imagine the processor of the size of all pin tip. So, let us know more about the evolution of present day processor. The history of computer goes back several decades. However, there are 5 definable generations of electronic computer. Each generation is recognized by a significant technological development that has changed the fundamental processing of the data. We started with huge vacuum tubes in the first generation from 1940 to 1956. The 2 prominent machines of this era were the UNIVAC and ENIAC machines. Then the replacement of vacuum tubes with transistors saw the advent of the second generation of the computing in 1956 to 1963. It changed the whole scenario of computing. Do you know who invented the first transistor? John Bardeen, Walter Brattain and William Shockley invented the first transistor at Bell Laboratories in 1947, and they were also awarded Nobel Prize in Physics for their discovery in 1956. The invention of transistor made computers smaller, faster, cheaper and less heavy on electricity use. Then came the advent of integrated circuits, the third generation from 1964 to 1971, made transistors more miniatured and put on silicon chip called as semiconductor. It was the Fairchild Semiconductor who invented the first IC in 1959. This invention brought revolution in the industry of processor, led to massive increase in the speed and efficiency of machine, and we entered the fourth generation of microprocessor from 1972 to 2010, being manufactured by the Intel. Do you know how Intel was founded? In 1968, Robert Noyce, Gordon Moore and Andrew Grove, who were working in the Fairchild Semiconductor, resigned from their job and established their own company, Intel. Yes, the Intel. Intel developed 4004 chip in 1971, which positioned all computer component, that is CPU, memory, input-output control onto a single chip, which could be accommodated in a palm of hand. This Intel chip housed thousands of integrated circuits. The year 1981 saw the first ever computer by IBM specifically designed for home use. It was also built around the Intel chip. And since 1981, Intel Corporation has been world's largest and highest valued semiconductor chip manufacturing and has been designing and manufacturing high performance processor for every usage, including enterprise scale servers, IoT devices, laptops, desktop, workstation and mobile devices. There are different generations of Intel. The invention of Intel 80 by 80 series of microprocessor is the most recognizable first generation chip, the type of processor found in most personal computers. Although 8088 was the first chip to be used in an IBM PC, IBM used 80 by 86 in the subsequent models called as IBM PC XT. The chip that came in subsequent generation of the Intel are 286, 386, 486, Pentium, which recognizes the fifth generation, Pentium Pro, Pentium 2nd, Pentium 3rd, Celeron, Pentium 4th, Xenon, Itanium line, Pentium dual core, Intel Core 2 Duo, Intel Core 2 Quad, and still continues with new advances. Remember, they all correspond to the design standard of 8086, the line of processor which are referred as 80 by 86 line. Do you know 8086 line architecture contained only a few thousand transistors, whereas Pentium 3 Xenon contained millions of transistors. This increasingly complex architecture is responsible for the unexpected power and speed of Intel processor. We have wide range of processors from other manufacturers such as Advanced Micro Device, that is AMD, VIA, Qualcomm, NVIDIA, IBM, Samsung, Motorola, HP, Dell, Acer, Cyrix, MediaTek, and many more. Each of these companies offer competitively priced processor chips with comparable performance to Intel processor. Presently, most accessible processors are from AMD and Intel, which show compatibility with most internal and external devices. Your selection of processor depends on your requirement and your budget. If you are a gaming freak, you need to have a fast processor. Beside gaming, computer devoted for some special purpose like video editing, serious audio work, computer aided designs or animation need to have dedicated processor. Dear friends, beyond 2010, we are working with 5th generation, the age of artificial intelligence, where we are assuming that computer can process and respond to natural languages and have capability to learn and manage itself. which have been made possible by using parallel processing and supercomputers. We are leaning towards the future computers, where we will be radically transformed by quantum computing, molecular and nanotechnology. So, we stop here. See you in the next module. Thanks for giving your time today. Goodbye.